Let's dive into more detail about scatter plots. So the Cartesian grid is the system developed by René Descartes for graphing points as ordered pairs on a grid, also referred to as the Cartesian plane, the coordinate grid, or the xy plane. There are 4 quadrants, and those quadrants are 1, 2, 3, and 4. So, when we talk about scale, scale is the interval that your x and y values increase by. A scale should use up as much of the grid as possible. So in this case, I went with every space is 1 unit. So 1, there's 2, 3, there's 4. I did it along my x, and I also scaled for 1 along my y-axis as well. Right, so points are listed as x and y. So we're going to quickly graph these points and label them and which quadrant they're in. So point A is 2 and 3. Well, my x value is 2, my y value is 3. My point is going to be right here. That is point A. Point B is -1 on the x and 4 for the y. -1 and 4 being right here for B. C, I have +6 along the x-axis and then -7 along my y. So I'm going to be right around here for C. And then D, I have +9, change the color, +9 and 0, which would be right here. So I know that this is in quadrant 1, this is in quadrant 2, I have nothing in quadrant 3, this is in quadrant 4, and then x would be directly between 1 and 4, or it's right along the x-axis. The independent variable is the variable that you need to know first. It determines the value of the dependent variable. We place these variables on the x-axis. I'm going to highlight this. Yeah, along the x-axis. These are usually values that you choose. So along the x-axis would be something like time or distance. A dependent variable is the variable which depends on the other. Independent depends on the other independent variable. We place these variables along the y-axis. So that is along the y-axis. These are usually values you measure in an experiment. So an example would be like distance traveled and how much gas is used. Those are examples that we will be coming into. So our first example, identify the independent and dependent variables of each situation. So does the outdoor temperature affect the fuel needed to heat the house? Well, which one is independent or kind of on its own? Well, this one, the outdoor temperature, would be independent, and the amount of fuel needed is dependent on the temperature. Is there a relationship between people's ages and their heights? Well, in this case, age would be independent, and height would be the dependent variable, or their height is dependent on their age. Does the mark on a test depend on the number of hours spent on homework? Well, number of hours, that would be a time. That would be my dependent. And then the mark on the test would be independent. It would be basically in direct relation to how many hours you spent on your homework. So this is a bit of a scatter plot checklist. So when we're doing a scatter plot, here are the things we need to know or to have. The independent variable goes along the x-axis. Dependent goes along the y. The scale should be selected so that at least half of the graph is used. Right? We don't want it to be too small or too big that we don't get all the information. The scale should be even, as in evenly spaced out. The axis should be labeled with units. The title should relate to the graph, and the points should be plotted correctly. So when we're making a scale, we determine the range in the values. Then we count the number of boxes we have on a grid, and then we divide the range by the number of boxes to determine a scale. So try to pick numbers with nice multiples. Okay. So I'm only going to really look at this left side here. So in 2000, a law was passed against the use of cell phones while driving in any town. what should the scale for x and the y-axis be for the 4 different grids below? So below I have 4 different grids, A, B, C, and D. Here is the information that I have from the year and the number of people, right? Dependent, independent. So when it comes to graph A, what should I set my x-axis scale to? And what should I set my y-axis scale to? Well, if you look at A, my x-axis is really long and my y-axis isn't so long. So if I look at my x-axis, well, these only go up by increments of 1 year. So I'm going to, every third tick mark, I'm going to place the next year. So I'm going to go every 3 spaces is where I'm going to place the next interval of the dependent variable. Along my y-axis, I need to fill everything from the bottom with the lowest number here would be 192, and the highest is 309. So I would be going in increments of 50. 50, 100, 50, 200, 50, 300. So that kind of fills up the majority of the graph. For grid B, which would be over here, a little bit of different story. My x-axis is pretty short, but my y-axis is long. So I can actually get away with an x-axis scale of 1. So I mean every line is one of those years. And then the y-axis scale, every increment could be 25. And then that way we would use the majority of this grid in an appropriate way. Graph C, I would set my x-axis scale to 1. Again, not a ton of space here, so I can put every single year interval along the x-axis spaced by 1. And I would go up every unit by 75 along the y-axis. That way I get the majority of the graph used, and I can include all the information. And for D, my x-axis, I would keep it at 1, but it's a really short y-axis, so then I would put every tick mark or every unit increment to be 100. 100, 200, 300, and then we can see that we would use the majority of the space on that grid. All right, let's get into some actually doing some scatter plots. A study was conducted which examines the number of hours a student sleeps before a test and their performance. The table below shows the result of this data. So here's hours slept, and here's the test scores. What is the independent variable? Well, the independent variable is hours slept. What is the dependent variable? Well, it would be the score of their test, right? Their score is dependent on how many hours of sleep they would get. So we're going to make a scatter plot of the data. So along my x-axis, I put hours slept, and I scaled it to be every 2 spaces to be 1. And you can see how I did that there. And along my y-axis would be my dependent variable, which in this case would be the score. So I've plotted the points right here with all the information given, and my scatter plot looks like this. So if the relationship exists, the points in a scatter plot will show a general pattern or trend. The outlier is a point separated from the main body of data on the graph. Sometimes an outlier from a measurement error or from some factor that affects only a few of the observed values for a variable. If you can show that an outlier is inaccurate or unrepresentative, you can leave it out of your calculations. Otherwise, you should include it. Okay, basically what that's saying is sometimes you get an anomaly where you have a piece of data like this, where you'd have an information of this student slept 8.5 hours but only scored 65, where that is not part of the trend. That would be an outlier. Do I have anything else? Oh, that would be it. Okay, so that would be how to construct the scatter plot, identifying what our independent variable is, our dependent variables, creating a scale along the x and y axis, and plotting our information on the scatter plot.